So for the introduction, time-varying magnetic fields are used in technologies like wireless charging, induction cookers, and metal detectors. According to Faraday's law, a changing magnetic field induces current in nearby conductors. Metal detectors use an AC coil to create a fluctuating magnetic field. When metal enters the field, eddy currents are induced and cause detectable signal changes. This project aims to build a working metal detector prototype with real-world applications in security and archaeology.
BE20303. Now I present about the problem statement. The problem statement is safety in public places like airport, school and large event is very important. This project uses the metal detector to detect hidden dangerous objects. However, many low-cost metal detectors have a problem such as low sensitivity, limited detection range, and cannot differentiate between harmful and harmless metals. This causes false alarm or failure to detect a real risk. In addition, most of these devices are not eco-friendly and contribute to electronic waste. Therefore, this project is aimed to develop a more accurate, reliable and eco-friendly metal detector to improve safety and sustainability.
Right, now let's move on with the objectives and the scope of work. Okay, first of all, to demonstrate the application of Faraday's law by inducing a voltage in a coil through a time-varying magnetic field, and then to analyze how the presence of conductive metals alters the magnetic field and induce detectable changes in the signal frequency or voltage. Last but not least, to construct a simple metal detector circuit using coils capable of detecting changes in magnetic flux caused by nearby metallic objects.
Right, my name is Muhammad Hakim bin Muhammad Nasr Hakim. We present about methodology. Alright, today ensuring safety in public areas such as airport, school, and even is more important than ever. Metal detector have in identifying hidden metal objects that could pose a threat. However, many affordable models suffer from low sensitivity and limited detection range, which reduce their effectiveness. They also struggle to differentiate between dangerous and harmless metal, often causing false alarms. And many of these devices are made from non-eco-friendly material, contributing to electronic waste and environmental issues. This project aims to address this challenge by developing a more reliable and eco-friendly metal detector. So that's all.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakim Hussein. My matrix number is BE2030118. So I'm from group 5. So our group makes some of project which is, we call it metal detector. I will show you the simulation of the metal detector, how the metal detector function to detect is it a metal items or not. So this is our group 5 prototype for metal detector. This one is a coil which is 100 turns. Switch to turn on and turn off. So as you can see, we have a buzzer from 12 volt, and then the IC555, the 3 type of capacitor which is from 2.2 microfarad and 4.7 microfarad, and then the resistor that we use is 1 kilo ohms, and also the battery come from 9 volt. Now let's take a look at the simulation for electromagnetic field and eddy current by using the metal detector. So now we switch on the metal detector. So the buzzer will show the humming or the sounds like noise, as you can listen. So this is the normal, which is no metal that coil detect. So I'll have some of item which is non-metal and also the metal. So what the different? The different come from the buzzer, which is the noise. So if we take it closer to the object that non-metal, the noise still same, but if we put it to the metal, listen, the sound is totally different. I use the clip which is made for metal. Means this is the metal item. That's the simulation of the metal detector. So from the simulation, we know the coil produces the electromagnetic fields that induce the eddy current, which is from the coil that closer to the metal, and it produces a different voice, a different noise, or different type of sound from the buzzer that we can detect that is metal item or non-metal item. So that's our group 5 simulation. That's all for me. Thank you.
My name is Muhammad Naim. So I want to explain the expected result. The expected outcome of this project is to develop a simple and functional metal detector using time-varying electromagnetic fields, and covering is chapter 3. First, the detector should efficiently identify nearby metal objects by sensing a change in magnetic flux and apply Faraday's law of induction. Next, we expect a better performance compared to basic models, which improve sensitivity, fewer detection errors, and more efficiency coil design. We also aim to support sustainability by using recycled materials where possible, promoting eco-friendly engineering. And finally, this hands-on experience strengthens our understanding of electromagnetic principles and show how they apply to real-world safety and engineering.